In this video, we're going to learn our final method of factoring quadratics. That is to factor quadratics that don't have a leading coefficient of 1. We're either going to use the box method or splitting the middle. And we're also going to learn how to then solve quadratics by factoring. If you're in my class and you're watching this video as your lesson today, please turn to page 4, pause the video, and work on warm-up problems 1 and 2. Okay, you should have worked on problem 1 on your own. For problem 1, I noticed that we have 2x squared and 18, and we can take out a 2. So we're going to go 2, and then we're left with x squared minus 9. And x squared minus 9 can factor to x plus 3, x minus 3, using the difference of two perfect squares. So that is our factoring for number 1. Number 2, I see I have 3, 6, and 24. Those are all divisible by 3. So when I factor out the 3, I'm left with 3x squared minus 2x minus 8. Now, because this is a 1, I have a trinomial that a is equal to 1. So I'm thinking, what adds to -2 and multiplies to -8, and the numbers are -4 and +2. I got to carry the 3 along. So this is the factorization for number 2. Okay, when we get to number 3, this is our new type, which is why I only asked you to do 1 and 2. So again, yesterday we talked about greatest common factor. We talked about binomials that were maybe the difference of perfect squares. We looked at trinomials, but only trinomials where a was equal to 1 using the add and multiply method. Today we're going to look at where a is not 1, boxing and splitting the middle, and then we're going to apply all the methods to solve. So the first thing we're going to do is we're going to notice that we have a 2 here. That's not 1. And I can't divide everything here by 2 like I divided everything by 3 in number 2. Now, first I'm going to start with split the middle. And it's called split the middle because we're literally going to take this middle term and we are going to split it. The first thing we want to do is write down that a is 2, b is 3, c is 1, like A, B, C. Once we do that, we're going to get into our steps. Step 1, we are going to multiply A times C. So in this problem, it's going to be 2 times 1, which is just 2. The second thing we're going to do is we are going to find two numbers that add to B, and I put the B in quotes so I know that I'm talking about like B is 3, and multiply to AC. So in this situation, I'm looking for two numbers that add to 3 and multiply to 2, and that is obviously going to be 2 and 1. So what I'm going to do is I'm going to literally take this middle term and I'm going to split it. I'm going to keep the 2x squared, and the 3x I'm going to split to 2 and 1. Okay, those are my two numbers. 2 and 1 add to 3 and multiply to AC. Then everything else just gets brought down. Okay, so now step 3. We are going to find, I guess really step 3 was really in purple. Let's put that in. Let's write that down. Split the middle terms. We did in purple, and now in blue, step 4, I'm going to find the GCF of the first two and of the last two. Here's what I mean. I'm going to group them together. First two, last two. If I just look at the first two, the greatest common factor is 2x. So I'm going to take that out. I'm going to have 2x plus 1. And now the second two just has a greatest common factor of 1. So I'm going to take that out as a placeholder, and this becomes 2x plus 1. And now my final step is going to be to rewrite as two binomials. Now, I want you to notice something. Don't write this down because I'm going to erase. Here, I have 2x times x, and we have 2x times 1. Here, I have 1 times x and 1 times 1. Notice that I have 4 little arcs there. If I rewrite this, 2x plus 1, okay, brought down the greatest common factors together. And what am I multiplying that by? X plus 1. That's the same thing as the 1, 2, 3, 4 steps of multiplication I had up on the blue line. So that is our final factorization. All right, what I would like you to do is I want you to write down another problem. We're going to practice splitting the middle one more time, and then I'm going to show you the box method. It's going to go a lot faster because we're not going to need to write down all the steps. So for number 4, go ahead and write this down on the same page. We're going to write down 4x squared plus 12x minus 7. And I'm going to go ahead and find, I know that I've got A is 4, B is 12, C is negative 7. And the first thing I'm going to do is 8 times C, and that's going to be negative 28. So now I'm looking for two numbers they have to add and multiply. So I'm going to think about what multiplies to negative 28. 1 and 28, and one of them would have to be negative, but that's going to not be too far apart. I can do 2 and 14 multiply. Oh yeah, that's going to work. If I make the 2 negative, that'll add to 12 and multiply to negative 28. So now I'm going to split the middle term. The 12x is going to become, I'm going to actually put the 14 first. I want to show you something. So I have 14x and negative 2x because, okay, that's the bell in the video. That's not the bell for you. Because 14 minus 2 is 12, and then minus 7. Again, I'm going to find the greatest common factor. So I'm going to group, oh, I forgot the squared. I'm going to group the first 2 terms and the last 2 terms. So now 4x squared plus 14x divides by 2x. Now, 2 and 7 don't have any common terms, but they're both negative. So I can take out a negative 1, and I'm left with, oh, whoops, I forgot the 2 here. 4 divided by 2 is 2. 2x plus 7 also. These have to match. Now I'm going to rewrite it. I bring down the 2x and the minus 1, and it's 2x minus 1, 2x plus 7. So that is the split the middle method of factoring. If you like that, fantastic. If you want to see one more, well, or if you just don't like it, let's do it. Here we go. Let's all write down one more, and then you can decide which method you like the best. So number 5, let's write down 3x squared minus x minus 10. Now we're going to use the box method, but it sort of starts the same way. We still need to start A is 3, B is negative 1, C is negative 10. So now AC is negative 30. I'm still looking for 2 numbers that add and multiply. Okay, those 2 numbers are going to be negative 6 and 5. Here's where it's different. Instead of splitting the middle term, I'm literally going to build a box. I'm going to build myself a little box. It's pretty big. Probably not even that big. That's okay. And here's what's going to happen. This first term is always going to go in the top left box. Oh, I meant to change colors. The constant term is always going to go in the bottom right box. So let's fill those in. We have 3x squared and negative 10. Now what's going to happen, instead of putting negative 1, I'm going to use the negative 6x and the 5x because they add to 1. You have to look at this little box like this is a multiplication table here. So we have to put up at the top here. we need to put here and here whatever will multiply to these 4 squares. I tell kids to always start with a nice prime number. So I'm going to start with the 3 because it's prime. Only 3 times 1 gives me 3. I don't want to put the 3 up here because this is a 5. I can't do 3 times something and get 5. But if I put 3 here, this is a 6. That's going to work out. So I'll make this 3x and this x because 3x times x is 3x squared. Now, 3x times what gives us negative 6x? Negative 2. I've got a negative 2, and it has to multiply to negative 10. Well, that can work if this is a 5, because 5 times negative 2 is negative 10, and it works out great because 5 times x is 5x. Then all I have to do is grab the top, x minus 2, grab what's going down the side, 3x plus 5, and there's my factorization. You can choose what method you like the best, split the middle or box. I'll probably do box one more time and then I'll alternate. All right, if you turn to page 2, we did not do these 3 yesterday. I'm going to do one of them with you, and then I'm just going to reveal the answers. You can practice those on your own. So I'm going to do 3x squared plus 7x minus 20 with the box method. So I have an A, B, and C. So A times C is going to be 60. Negative 60. So let me think. We'll multiply 60. 2 and 30. 3 and 20. 4. Does 4 go into 60? 4 goes in 15 times. That'll be 11. 5 and 12. Oh, 5 and 12. 5 and 12. If I make the 5 negative, that will work. So now I'm going to build the box. Again, the squared term goes in the top left. The constant goes in the bottom right. I'm going to split 7 into negative 5x plus 12 because that gives me 7x. I want to pick a prime number to start with. So either I'm going to pick the 3 or the 5. It does not matter. I'll pick the 5 because I see these 2 negatives lined up. That tells me this number has to be negative. I'll put the 5 here. I can't put the x here because the 20 doesn't have the x, so the x will go here. X times negative 5 is negative 5x. Now this is 3x squared, so this needs to be 3x. 3x times what gives me 12x? 4. And just as a check, 4 times negative 5 is indeed negative 20. So my factoring is 3x minus 5x plus 4. Yep. And it's okay if they're not in the same order, as long as they are the same numbers. I'll do number 7 also, and then you do number 8 on your own. I'll do number 7 with split the middle. Obviously, you can stop the video and just do it by yourself. You don't need to watch me do this. So, but you need to do number 7. Number 7, I've got 4x squared plus 31x minus 8. So AC is going to be negative. Oh, that's not bad at all, because that means I'll just use 32 and negative 1. I'm going to split the middle here. So I've got 4x squared plus 32x minus 1x minus 8. Oh, and here's that situation again. I know that I'm going to be taking a negative 1 and a 4x. Oops, got the minus 1. So my final solution will be 4x minus 1 x plus 8. At this point, you should pause the video and try number 8 by yourself. Hopefully for number 8, you got 3x plus 2, 5x minus 1. And it is perfectly okay if you have those in a different order. All right, so the reason we go through all of this is so that we can solve. Okay, go ahead, if you're in my class, turn to page 5. You don't have this at the top. It's review. You can write it down, pause the video and write it down if you want. As a reminder, the zero product property states if the product of two factors is zero, then at least one of the factors is zero. So in symbols, for any numbers a, b, and c, if a times b equals zero, either a equals zero or b equals zero. We have 4 problems on this page. We are going to determine what factoring method we're going to use, and then we're going to apply it to solve using the zero product property. So number 1, I see x squared plus 64. So I'm going to use that flow chart on the previous page. Is there a greatest common factor? No. Is it a binomial or a trinomial? There are 2 terms. It's a binomial. Is it the difference of perfect squares? Yes, it's subtraction. 64 and x squared are both perfect squares. So perfect squares. So what squared gives you x? X. Or x squared is x. It's going to be x plus 8, x minus 8. Both factors contain a variable, so both of them could be 0. So if I subtract 8 here, I get x equals -8. If I add 8 here, I get +8. Okay, number 2. And again, feel free to pause the video, work on your own. I see that I have no greatest common factor and it starts with a 1. It's a trinomial that starts with 1, so I'm going to go a equals 1, what adds and multiplies. Oops, it's not coming out. So what adds to -1 and multiplies to -20 is going to be -5 and +4. So then I can set each one equal to 0. I get x equals 5 and x equals -4. Why don't you pause the video, take a look at 3 and 4, and see if you can figure out what factoring method to use. The first thing you should notice is they're not in standard form, so I need to add 12 to both sides. And that's going to give me 2x squared minus 11x plus 12 equals 0. Think to yourself, what factoring method should I use here? There's no greatest common factor. It's a trinomial, and it starts with a 2. So if you said a is not 1, split or box, you're correct. The last one, I split the middle, so this one will box. If you want to split the middle, by all means do that. Again, feel free to pause the video and try this on your own, and then check back in to see if you're doing it correctly. So I know that I'm trying to add to -11, and I'm trying to multiply to 24. So my numbers are going to be -8 and +3. Let's build the box. Squared term, constant term. The -11, oops, that should have been a -3. The -11 is going to become -8x and -3x. Now, when I go to put my factors on the side, I can choose the 2 or the 3 to work with. I don't want to do the 8 and the 12. They're not prime. I'm going to do the 2 because it's positive. So the question is, can the 2 go on the top or on the side? It should go on the side, because if I put it on the top, that's a 3. That's not going to work out. So we'll do 2x and x. I have 2x, and this is -8, so -4. I have x, and this is -3x, so -3. That makes our factors 2x minus 3, x minus 4. Set each factor equal to 0. We get x equals 3/2. And x equals 4. Oh, that's an ugly 3/2. Oh, well. Number 4. Hopefully you notice number 4 is not in standard form either. So I'm going to subtract 5x from both sides. And that gives us x squared minus 5x equals 0. Take a second and think about what factoring method we should use here. Hopefully you decided to use greatest common factor because they both contain an x. If I take out the x, I'm left with x squared minus 5. I'm going to set this factor equal to 0, and it's done. Ooh, that one should not be there. I'm going to set x minus 5 equal to 0. Add 5 to both sides, and I get my solutions are 0 and 5. Your homework tonight is to complete page 3, numbers 34 to 45, and make sure you show all your work. You should be working on a separate sheet of paper. I'll put the answers up now so you can check using this video. If all you have are answers, though, that's going to be real sad for you tomorrow.